Me disse que nós temos 20 minutos, né, para perguntas, devido à necessidade de a gente esvaziar a sala e preparar para a apresentação no plenário principal. Recebi várias perguntas, vou tentar fazer o máximo que eu puder aqui nesse tempo, e as que sobrarem nós vamos passar para o palestrante, que ele poderá ou entrar em contato com vocês por e-mail que vocês colocaram aqui no formulário, ou uma interação eventual aí no corredor. Vou começar por algumas perguntas aqui para o Steen. Steen, this is the first one for you, okay? It comes from Jadir Oliveira from Prozim Biosolutions, and he says that the demand for enzymes must be enormous according to your projections. He asks if Novozymes is investing in local production. He probably is asking if you're going to plan for plants for local production.
Yeah, thank you. You're quite right that it would need us to build more capacity. Right now, the expectations that we have is that the U.S. is ready to fly next year. And in anticipation of that, we are actually building, as we speak, a big facility, enzyme producing facility in Nebraska, in Blair, Nebraska. We will hopefully also have to build a facility here in Brazil. We already have one in Curitiba to supply the potential in Brazil. We would need an additional factory. I like to state here that we are now in a position where what used to be a necessity, which was people who talked about on-site enzyme production, that is, if you built a second generation facility, you would also have to build at the same time an enzyme facility on site because of the massive amounts of enzymes that were needed originally. We have overcome that. We now can produce very potent enzymes so that we can simply truck the enzymes to the facilities with the technology we have developed in the meantime. So I think a very important message is that we are ready next year, and we are building the facility in anticipation of that in the United States, and we'll do the same here in Brazil as soon as we are ready here.
Okay, thank you. Question for Ricardo Madureira. The person didn't identify himself. What are the benefits of planting energy cane instead of traditional cane if we had the choice? Is this worth losing the sugar sucrose production for more biomass?
Okay, thanks. When we started the breeding program focused on biomass, it was 3 years ago, and our idea was to develop the future sugar cane or energy cane when we have this second generation ethanol available, industrial available. So today, but although it's a future project, we start to develop the opportunity to use it as a source of increasing the biomass to produce energy on the grid, to burn, produce a turbine and to produce energy on the grid. So you are right. I mean, today the sugarcane as it is, with focus on sucrose, is the most important thing. And most part of our breeding program is focused on sucrose per hectare, as I showed. But we believe that we need to invest part of our breeding program thinking of the sugarcane in the future. So when we have the technology available to break the biomass, release the sugar, definitely this will be a very valuable cane. But today you are right. I mean, we have to focus on the conventional one.
This question was addressed for the two foreign speakers here. The question is regarding the logistics for the collection of biomass. The question is that the logistics for biomass in Brazil is already solved with the bagasse that's available today in the mills. And the question is, what are the perspectives of addressing these questions in the U.S. since the volumes of biomass to convert to second generation will be enormous? What is being done in terms of logistics for this collection of biomass? You want to answer that, Ian?
Is the microphone working?
Yes.
Yep. So the short answer is copy the Brazil model, actually. Really, the problem is the same. It's about getting, at least in terms of what we're doing, a crop almost identical to sugarcane from land around the plant to the central facility. So I think we'd be looking here for some of those solutions, actually.
Do you want me to give it? Yeah. In the U.S., where the focus initially for many of the players are on the residues from corn, the focus initially is on the corn cobs, of which there's sufficient for the production of 5 billion gallons of fuel ethanol in the United States. As we speak, collection systems are being developed so that the farmer can bring in the corn and the corn cobs more or less at the same time. And if you want to see a good demonstration, you can go to the Poet website and see a video of how they're working with the farmers in Poet. Thanks.
Ok, tem uma pergunta do Francisco Almeida Neto, da Chemtech, que ele pergunta qual o incremento obtido com o aumento de fibras na cana, nos canaviais do Brasil. Acho que ele está perguntando, talvez futuramente, qual vai ser o aumento de produtividade, mas deve ser de açúcar e de álcool baseado em mais fibras na cana.
Eu trouxe até uma cola aqui para alguns números que a gente tem. O que a gente acha que a gente, energy cane ou fiber cane, ou a gente poderia ter em termos de dry matter ou matéria seca, em torno de 57 toneladas por hectare por ano. Só para comparar, uma cana-de-açúcar convencional tem 26,6. Isso é próximo, um pouco mais do que o dobro de quantidade de matéria seca de cana. E se você comparar, por exemplo, com eucaliptos, né, eucalipto que também é usado como uma fonte de biomassa para bioenergia, eucalipto, se você pegar um ciclo de 7 anos, né, o ciclo de crescimento do eucalipto, dá em torno de 25 toneladas por hectare por ano. Então, como eu falei, existe possibilidade que, como um cana-de-açúcar, focado mais na produção de fibra, de você pelo menos dobrar essa quantidade de matéria seca, né? Eu passei, o tempo da apresentação era curto, então realmente não dá para focar, mas quando você, aqueles materiais, eles tinham um pouco de açúcar também. Pouco em relação, percentual em relação a uma cana convencional, mas ainda tinha um pouco de açúcar. O que quer dizer que, para uma empresa que quer queimar a biomassa para gerar energia só por conta da energia, isso é um problema, porque ainda existe um resíduo de açúcar e de líquido ali, ainda existe uma umidade ali. Por outro lado, para a usina de cana-de-açúcar hoje, é um material que tem muita biomassa e pouco açúcar, então também não faz sentido. Então, nós estamos numa fase de definir o conceito de produto. O que é essa cana do futuro voltada para a biomassa? Não pode ter nenhum açúcar, ou você pode ter algum açúcar, você tem que ter um ajuste das moedas para poder fazer isso. Então, ele é uma coisa que tem que ser feita em conjunto com a parte industrial também. Mas, como eu falei, não existe, e outras pessoas hoje pela manhã também falaram sobre isso, não existe nada como cana-de-açúcar para gerar biomassa nos trópicos. Então, se você direciona seu programa de melhoramento para a geração de biomassa, você tem a oportunidade de gerar muito mais. É o que a gente tem visto no campo, no mínimo o dobro disso, mas alguns materiais pode chegar até o triplo da quantidade de biomassa. Mas, como eu falei, a gente precisa entender melhor esse conceito de produto e em que casos esse tipo de material pode e deve ser usado.
Okay, a question for Steen Riisgaard. This comes from Antonio Figueira of the University of São Paulo, Sena. What's the volume of residues generated by enzymatic hydrolysis? What's the expected use of these residues?
Well, it depends on exactly where you are, but the best use of the residues will be to generate power and steam for the production facility. And this would certainly be an option in Brazil, but it's also an option which is being considered in the United States.
I have a question for Ian. Comes from a gentleman called Gary Schweindeman from Etanol Capital Management in New York. He asks, why can Brazil run 20 to 25% in regular cars and US is limited to 10%? If butanol is ideal, why isn't it the dominant in the market?
First the question about Brazilian cars. The Brazilian cars running 22% ethanol are not identical to the American cars that are running 10%. Fundamentally, the car manufacturers might even be putting cars out there that can cope with more than 10%, but if they won't give you a warranty on things like the catalyst, etc., then you have some difficulties. And there certainly are cars out there that don't easily cope with more than 10%. So it's a historic thing. The market in Brazil has been using ethanol for a long time, and the cars have evolved to cope with the levels that are used here. Indeed, there are some car markets around the world that do struggle with 5% ethanol. So I know it seems obvious when you see the cars here happily driving around on more than 20% ethanol, but nevertheless there are different parts, both metal parts and elastomeric parts that will fail with those levels. Turning to the butanol question, the answer is very simple. The reason that butanol, even though it has excellent properties, the reason it isn't the main biofuel at the moment is you can't make it cheaply enough until we've finished developing the process that we're developing. There is an old-fashioned process for biobutanol, a thing called the ABE process, which makes multiple products, but for the chemists out there, it also makes one butanol, which is actually the low-octane version of butanol, and indeed the most toxic of the different isomers of butanol. And that means that it's very difficult to make it biologically at an economic price. So what we're doing is quite different from that, and will change the price point quite substantially. So that's the reason.
Okay, we have also a question here for Steen Riisgaard, Novozymes. It's the same person from New York. He asks if there is a problem in the collection and storage of agricultural waste. I think he's asking if there's any issue of storing this waste, and if you have any progress regarding wood to ethanol conversion.
Yeah, obviously the whole infrastructure for collection of bio waste will have to be built. As I said, POET is quite advanced in this, so are other people in the United States. They are similarly in China, infrastructure is being kind of developed on the drawing board. That's the first question. The second question, whether we are ready for wood chips, the answer is no, we are not. We have been concentrating on corn residues and bagasse, and later we'll turn to wheat straw. And the challenge of wood chips is a formidable one that we will crack one day, but we will take the easy ones first.
Okay, there is a question for Ricardo Madureira. It comes from Mr. Yelu Yamamoto from Honda. He asks Ricardo if you develop sugarcane with more cellulose, the level of sucrose will go down. Will there an increase in productivity this way?
Yeah, you're right. I mean, the productivity in sucrose per hectare will go down. I mean, that's why this is a kind of a crop that wouldn't be valuable to the market. It is